11.10, we're going to talk geometric probability. You've probably heard of probability a million times before in all of your other math classes. I know we talk about it in algebra just a little bit. Probability of an event happening is the ratio of the number of favorable outcomes to the number of possible outcomes. So often you might be talking about, everybody's heard this problem, you have 8 marbles in a bag. 8 red marbles out of a total of 12 total marbles. What's the likelihood that you pick a red marble out of this bag? I would make this a fraction of 2/3, and then as a percent, that's like a 66.7% chance. Why won't this work? Okay, it's fine. 66.7% chance that you pull a red marble, right? We've heard probability in this sense before. So what we're going to talk about is the probability of things happening in geometry. Sometimes you will see this in terms of lengths. Most of the time, what we're going to talk about in this unit is the probability of areas, which is this little formula down here. Basically, if you imagine a dartboard, that's like the most common analogy that I think of when I talk about geometric probability. If you think about a dartboard, what's the probability that if you throw your dart at the dartboard that it lands on the bullseye? You would take the area of the bullseye, which is our favorable outcome, over the area of the entire bullseye. Off of the entire target, the entire dartboard. So that's kind of what we're going to get at here. We're going to do 2 examples of this. They're pretty much the exact same stuff that we were doing yesterday. So in example 1, it says find the probability of landing in the shaded area. So the first thing we have to do is figure out what is the size of that entire dartboard, quote unquote, because we're imagining throwing a dart still. So the entire shape, the entire silhouette here is a square. So I'm going to call this the area of the entire shape, which I know is side squared because it's a squared. And now we need to figure out what is the length of that side. So I'm going to zoom in here. And we're going to use what we know to figure out the area of this square. So I know that the apothem of that little triangle is 6 inches. That's the apothem. Then I need to draw in my radius and figure out what is the length of the base of that square. So if the apothem is 6 inches, let's talk about our 30, 60, 90s. There's 60. There's 30. So then the long leg here is 6 radical 3. That makes 1 full side of my square, 12 radical 3. And we're going to go ahead and put that into our formula for area of our square. If it wants to load, I don't know what's going on. Oh, well, okay, my entire thing just erased. That's awesome. Area of the entire thing is side squared, or 12 radical 3 squared. One important thing to remember, if we are doing this by hand, that both the 12 and the 3 are squared, so this is actually 144 times 3, or it ends up being 432 inches squared. That's the area of my entire dartboard, quote unquote. It's a square dartboard. Then we need to figure out the area of the shaded region. To figure out the area of the shaded region, we're going to do exactly what we did yesterday, which is we're going to use one of our 2 methods. This time, let's use the hole puncher method. I'm going to take the entire area. I'm going to punch out or subtract that triangle in the center. So 432 is my whole area minus the area of this triangle, which let me put my markings back in here since they decided they wanted to go away. The last piece here, the radius is 12. So to find the area of that equilateral triangle, I'm going to go ahead and do 1/2 times the apothem, which is 6, times the perimeter of this triangle. One side is 12 radical 3, so 3 sides is 36 radical 3. We can plug that whole thing into our calculator and get a nice ugly decimal. I believe you should get 244.9 inches squared. Any questions on that? That's basically what we did yesterday. We feel confident about that? Okay. The last step then is to figure out the probability that we land in that shaded region. So we're going to say the probability that we land in the favorable area is the area of the favorable, so 244.9 over the entire area for 32 inches squared. When we put that number into our calculator, we're going to get a nice decimal. It's going to come out to 0.5668. Something. All of our final answers for this section should be in percentages. So I'm going to take that decimal. I'm going to move the decimal place over 2 spots and round 1 decimal place is fine with me, 56.7%. So if I throw a dart, I'm not very skilled at darts, so I'm kind of just chucking it at the board. If I throw that dart, the probability that I land in that shaded region is 56.7%. Sound good? Do it one more time and then we're done. So number 2, same idea. We're going to do it with circles. Remember, I'm kind of trying to emphasize the idea of not rounding until we absolutely have to. So especially when we talk about circles, I'm going to try to leave my answers in terms of pi. So the first thing I need to do, find the probability of hitting the red ring. I'm going to find the area of the entire region. The area of the entire region is going to be this circle, this large circle. It has a radius of 7 centimeters. So this is pi times 7 squared, or 49 pi centimeters squared. Everybody cool with that? Then I need to find the area that is shaded. What do we think we're going to do here to find that shaded area? What's our process look like? Allegra?
You pi it 5 squared and then take away pi 3 squared.
Perfect. We're going to find the area of that medium triangle, the one that's in red. So that's pi times the radius is 5 squared. And we're going to subtract away the part in the center that we don't want. So that's pi times 3 squared. That's our small circle. So this gets me 25 pi minus 9 pi, or 16 pi centimeters squared. This thing is so cooperative. Okay. So the shaded area is 16 pi centimeters squared. We are going to finish this off by doing the probability that I land in the favorable region is 16 pi centimeters squared, the shaded area, over the total area. Okay, listen to me when I say this. The easiest way to do this problem is to cancel out those pi's. Pi over pi cancels out nicely. You get 16 over 49. However, if you're like, I'm just going to stick the whole thing in my calculator, you have to be super careful because your calculator gets funky when we talk about dividing by pi's. It sees when you type in 16 pi divided by 49 pi, it sees this as 16 times pi divided by 49, and then that whole thing multiplied by pi, which is not what we want, right? We want this whole thing to be divided. So you have to put them in parentheses if you're leaving those pi's in your calculators, or your calculator is going to freak out doing order of operations. Yes? So if you're getting weird numbers, you're like, I don't know if 700% is correct, Miss Lees. It's because you didn't divide by your pi's correctly. So, that being said, in my calculators, I like to just do 16 divided by 49, make my life easy. This is 0.3265. I'm going to convert that to a percentage, 32.7%. Everybody happy with that?